this is lesson 10.6, and it has to do with segments inside the circle. So basically, if you have two segments like this inside the circle, to find out how to do it, you just, let's look at this line right here, the green, okay? All it is x plus 2 times x plus 1 is going to equal the same as this other line. Let's call him the red one. So it's going to equal this guy. So we say x times x plus 4. Now we just solve this, okay? So x times x is x squared. And then x times 1 is plus 1x. Then 2 times x is plus 2x. And then 2 times 1 is plus 2. And that's going to equal x times x is x squared. And x times 4 is positive 4x. Now we just simplify. Well, let's simplify in blue. All right, so I'm going to pull this x squared over. And I'm going to go minus x squared here. And minus x squared here. Well, it goes bye-bye on both sections. See that? All right, now I can actually combine these guys. So 1x plus 2x, 3x plus 2 equals what? 4x, okay? And then I'm just going to bring this guy over here. So negative 3x, negative 3x. So I just subtract, and 2 equals 1x, or just x. So now we know that x equals 2. Now, but that's not what they're asking. They're asking us to find ML and JK. They're asking us to find how long is the green line and how long is the red line. All right, well, let me do some erasing here a minute real quick, okay? We know that x is 2. Don't forget. All right, x is 2. Okay, so let's do green first. So x plus 2, and then there's x plus 1, right? So 2 plus 2 plus 2 plus 1 equals 7. So ML is 7. All right, now let's do the red one. X plus x plus 4. So it's going to be 2 plus 2 plus 4, and that's going to equal 8. So JK is 8. Now, you see, you can't think that they're the same length just because we multiplied them. It's kind of the ratio kind of a deal. All right, that's example 1. Let's go on to example 2. Okay, in example 2, which is on page 571 in your book, I've drawn the picture here. This is a secant line. Did I do this wrong? No. There are two secant lines, as a matter of fact. So there are two secant lines because they go through the circle. We could have extended that. And this is called the secant part. And this right here is called the external secant part, but it doesn't matter. All right, so to find out, we can solve problems like this. What you do is you say, this, the little baby green, times the whole green, is the same as the little tiny red times the whole red. So I just say, EA, I say little times big equals little, I know it's not a very mathematical way, times big, but that's what you do. All right, let me give you an example of that. Okay, so in this example, we're trying to find out what x equals right here. Okay, so let's look at the top line, and let's look at the bottom line. We'll call this green, okay. All right, so we're going to have the little, which is 10, times the whole thing, which is 10 plus x. So 10 times 10 plus x is going to equal, now we're going to do the red line, okay? And the red line is going to be 9 times the whole thing, which is 9 plus 11. Okay, so now we just use the distributive property. 10 times 10 is 100, plus 10x equals 9 times 9 is 81, plus 9 times 11 is 99. And since I don't have a calculator, I'm going to go over here and add this together. So that's 10, carry the 1, 18. All right. So, okay. So 100 plus 10x equals 180. I'm just going to finish it up with, doesn't matter about the colors. So I'll just go minus 180, or excuse me, minus 100, hello. Minus 100. And 10x equals 80, and x just equals 8. Okay, so, yeah, so x equals 8. And that's the answer to that. That's how you do it. Please write these notes down so you don't have to keep flipping through this lecture. Now this example, by the way, this is example 3 on page 572. Example 3 on page 572. Now you see how it looks different, but it really isn't different. You know, the last one had a line that went up like this. It extended, and we went the little times the big equals the little times the big. Well, we're going to kind of do that this way, this time as well. But, but this does not, you know, there's no, the line stops here. It's like a tangent line. But this is the secant line. ED is the secant line. All right, so to solve this, we're just going to say EC times the whole thing, which is ED, is going to just equal EA. Basically, it's EA times EA again, because you need another one. You need two of them. Or we could have said EA squared. That's all it is. So it's EC times ED equals EA squared. So that's the formula that you're going to use. All right? All right, let's do an example of that. Okay, let's call this 16. Let's call this X. Let's call this 8. Okay, I'm just looking at example 3. All right, so all we have to do is we're going to say X times the whole thing, which is X plus 8, is the same as 16 times 16, or 16 squared. Okay? So let's do this. X squared plus 8x equals, 16 times 16, 36, 9, 6, 1, 6, 15, 256, right? You'd think I'd know that by now. 256. Now I'm going to bring the 256 over to the left and then just factor. So x squared plus 8x minus 256. And then I'm just going to factor those two things. And well, your book is going to use the quadratic formula to solve this. But for right now, if you guys would give me this answer right here, I would count it. If you give me that answer right there, I will count it. But I think I will do another video on showing you how to do the quadratic formula. But for right now, that's good. The last example in this section is example 4 on page 572. And they're asking us to find the radius. Well, this is the radius. By the way, guys, some of you have been thinking that it's the diameter when it's not labeled as such. if it is a diameter, they're always going to label it with this dot, with the center point in the middle. Okay, they'll show you that center point. Then you know that's a radius. Okay, I mean, you know this is a diameter because they're showing that. Okay, well, we do this the exact same way. We want to find this. We want to find the radius. Okay, yeah, which we'll call r. Okay, so to solve it, we're going to go this 20 times 20, because remember, there's nothing else that goes up here, so we have to just do this twice. 20 times 20 equals 8, the baby part, times the whole thing, which is r plus 8, right? Well, all right, so that's 20 times 20 is just 400. Let's just put that down there right now. And this is really 8 times 2 of these r's plus 8. You see how I'm simplifying that? Okay, so 8 times 2r, so 400 equals 8 times 2r, that's 16r plus 64, because it's 8 times 8. Okay, so far so good? All right, so then I'm going to minus 64 on this side, minus 64, so I have 336 left. 336 equals 16r, and then I divide by 16, and r is going to equal 21. When you divide that in, it just goes r is 21. So the radius of the circle, 21, 21 and 8. Okay? And that's how you do that.